All right, so this little tiny, what size is this? It's an air conditioning unit, and I'm not sure if it's a 7,000 BTU. There's part numbers on the side if somebody wants to look it up. But in this room needs air conditioning, and this is a room that has lights in it, so it has a lot of heat. It has a dehumidifier, so that puts out heat. The problem is you don't want to run one of those ACs that suck the room negative. So this is an air conditioning unit that has an intake and an exhaust instead of one of the air conditioning units that you get from Home Depot that only have one outlet, and it sucks the air out of your room that you're already paying money to cool. It sucks that cool air out of the room and throws it outside. This way we have the air coming from outside right there through the wall. It's coming from outside. It's not inside this building envelope here. Then it's going out here to compensate, because there's going to be there, we got a 90 degree, there's going to be a 90 degree right here, right into another 90 degree. That is the absolute worst thing you can do with ducting, is have two 90 degrees into each other. Then it's going to go into a blower motor right there that has a fan adjust speed. So one of these blower motors, and it has an adjustable fan. Then it goes right into another 90. And then we already took out up above, about 18 feet above, there was a 180 degree loop that went out like 6 feet, and then it turned around in 180 degrees with the flex duct, and then it went up, totally stopping the airflow, just using flex duct going into a sharp 180. We got rid of that 18 feet up, and we made this go straight through the roof. It was already through the roof, but they really messed up the way they had it, and so we made this a straight shot. Well, you cannot have that little tiny fan. You see that little tiny fan down inside there? You cannot have that little tiny blower fan trying to push that column air. That's an 8-inch duct. You cannot have that going straight into a 90, straight into a 90, a 90, a 90, and then you got another 90, and then you got another 18, and then through the roof another 24 feet going all the way out to the roof. So that is why we're going to adjust it with this fan here. I'm going to take the pressure measurements of this and take the static pressure of the original duct that came with this. It had like a little 6-foot tube or something like that. I'm just going to hold it down in there, take the static pressure with a probe, and see what the static pressure is. Then all this is going to be sealed up and taped, and I'll put a static probe just before the motor, and I'll turn it on, and there's going to be a higher static pressure, and then adjust the speed of the blower motor that's going to go right here. It could go way faster than we need. Adjust the speed of the motor until the static pressure is like near zero or identical to whatever the static pressure was with the factory supplied tubing in a straight position. So we neutral out the back pressure caused by the static friction of all this ducting and all these 90s going all the way. So we're back to the OEM specification of what this unit was meant to be operated at. All right, see you guys later. You'll see the next shot when this thing is all installed.